Hello everyone, welcome to this video where we're going to look at how we can use SRAM to model and analyze a space truss. And this process will involve some clever usage of the cylindrical grid systems and the clone tool as well. So I'm going to start off by actually using the grid tool and going to the edit grids dialog here. And with this edit grids dialog, I'm going to define a couple new grids. So here I've got the existing grids in my model, and I'm going to create some new ones. So I'm going to right click on this field here, select new grid set. I'll call this one here outside grid. And I'm going to do this once more. I'm going to right click on new grid set, and as you can imagine, this one's going to be called inside grid. And I'm going to use this as kind of a guide for laying out my inside and outside chords, or my top and bottom chords of my truss that I'm going to create. Now the geometry and the parameters that I'm entering are purely arbitrary. You can adjust them as you see fit. This is just for demonstration. It doesn't represent a real structure that you might want to design. When I'm doing this here, you'll notice that I have the ability to select this grid and open it up. And when I do that, I have parameters behind that grid set that I can define. So here I can obviously display the grid, I can lock joints to grids, and I can lock the grid, which I'll do for now. And then I can turn on the grid type to either be Cartesian or cylindrical. And as I mentioned already, we're going to use a cylindrical approach. And I'm going to define this grid as basically a portion of the arch that I'm going to define for my space truss. So I'm going to start by defining the X grid spaces, and you can see for this radial or cylindrical grid we have the number of grids and then the radius. So here I'm going to define the number of grids as 1 at a radius of 0 millimeters. So it's basically just the insertion point or the coordinate system origin. And then I'm going to have another one here. It's going to have a radius of 20 meters or 20,000 millimeters. I could change my units if I wanted to as well. So this is the X grid definition. I'm going to do the same thing for the Y grid, but you can see here the parameters have changed slightly. So it's the number of grids and then the theta angle of rotation. So I'm going to go with one grid at theta equals 0. And I'm going to define 20 more. And this is going to be at theta equals 4.5 degrees. And we can get a little preview of what's showing up here. And you'll notice here that it's occupying this 90-degree quadrant. But that may not necessarily be where I want this to be located. I actually want this to kind of be evenly distributed on either side of the y-axis. So I can unlock this grid here, and I can say, let's apply an angle of rotation to this. Let's make it a 45-degree angle. And we can click OK. And just to see what we're looking at here, let me look at the top-down view. And we can see that it fans out over this orientation here. Now I could have made it wider than that if I wanted to, but I'm just using the area that I want to draw for my particular space truss. So I got my outside grid defined now. I'm going to do the same thing by going back into the edit grids dialog and just select the inside grid folder here and define similar parameters. So it's again a cylindrical grid. I'm going to set up the grid spacing here. So for the X grid spacing, it's going to be the same thing, 1 at 0 and then 1 at 2 meters smaller radius, 18 meters. And then for the Y grid spacing, I'm actually going to make this a little bit of a tighter increment. So I'm going to say that we have additional grid spacing, or grid lines rather. I have 40, and at a tighter increment as well, 2.25 degrees. So we can see what we're left with there. And the angle, again, I'm going to make this 45 degrees. And now we can actually see that grid showing up on our screen, just like we had intended to look at it there. I'll click OK. And we can start drawing in our grids, or our geometry using these grids. So the first thing I want to do is make sure I'm selecting the correct grid. I'll start with the outside grid. And I like to use folders, so I'm actually going to right click on this folder. And I'm going to say, let's create a new grid, and this one's going to be called outside start. You'll see why I call it that in just a minute. And all I'm going to do is I'm going to use the member definition tool. And let me just define a cross section as well. I'll just grab a HSS section here. Let me just choose one. I'll do a 203 by 203 by 13 and add this to my model. And now with the member definition tool, I'm going to use a two joints method and basically draw in this grid or along this grid here. And you'll notice that I'm using the continue from last joint option, which basically allows me to draw a chain of grids, or members rather, along my grid, rather than left clicking the start point each time I want to create a new member. So this will be a fairly manual process from this point. You can see here we're just clicking along. And once I get to the end, I can end the command. And it's worth noting here that we can use the coordinate system origin and the clone tool to facilitate faster creation of this repetitive geometry about this type of pattern. I'm going through and showing you a few different options to work with. One of them being we can use the brute force method of drawing these members in, or we could be a little bit more intelligent with this approach, like we'll see later on, and actually draw in maybe one or two of these elements and then clone them about a pattern that we might want to use. I'm also going to update this folder here. So I'm going to say, let's just go ahead and update this open group with the selected content. Now I'll go through and I'm going to create my second folder. This one is going to be called inside. I'm going to select this, and for this one here, I'm going to switch to my inside grid. And I'm going to do something similar, the two joints method. I'm just going to start in one increment further. And then I end that command. And again, I could have done this the same way where I used the clone tool as well, but we'll look at that later on. So I'm going to right click, update my open group, and now I have these two objects selected. The next step is to actually offset the top chord. So I'm going to use the outside start folder that I created. And you might see now why I called it outside start, because I'm going to copy this, Control C on my keyboard, or go to Edit, Copy, does the same thing. And I'm going to use the clone tool. So I'm going to use the clone tool here, and I'm going to right click on the clone tool and basically create two copies of this. You'll notice here that I have my Z axis coming out of the screen towards us. So that's the direction I want to copy in. So I'm going to set up two different copies, one at 1000 millimeters in the positive direction and one at 1000 millimeters in the negative direction. And I think the easiest way to do that for this situation here is just to go with first copy increment of 1000 millimeters. And I'm going to create an additional copy in the Z-axis of negative 2000 millimeters. So that's an offset from this first copy point. And I'll click OK. And all of the objects in the clipboard, which are currently shown in red here, are going to be copied in that type of arrangement. So I'll click OK. And let me just look at my isometric view so we can identify this a little bit more clearly. And we can clearly see that we do have these offsets that have been defined for us. And what's left in the middle is something that I can actually delete. So I can get rid of the elements in this, this folder that's currently selected. So I'm going to use the member definition tool. Left click on it, because I use that tool to create the members. I can left click, so I can hold down Control on my keyboard with the member definition tool, and left click and drag around all of these members that are currently selected. And it's going to get rid of just those members, and it's going to leave those joints. So I'm going to get rid of those joints too, doing the same command. Use the joint tool, hold down Control on my keyboard to enact a reverse functionality of what it would have originally done, and then left click and drag. And you can see now we're left with basically the remnants of our top chord and our bottom chord, and obviously our grids. But I don't really need the grids at this point, so I can just hide them. And I can go back to viewing my model here, and what I want to do is I actually want to select the whole structure and start drawing in my chords, or my web members, sorry. So here I'm going to go with the member definition tool, just like I showed before. I'm going to use the two joints method, but I'm going to configure this to set it up for truss element types, which are axial, have only axial stiffness. So I'll click truss, and I have also kept this continue from last joint chain definition method. And what I can do is I can basically start drawing in the shape of my truss here, the web elements in my truss. So I'm starting here and basically just tracing out the general shape that I'll be working with. So I'm just going to create maybe one example of this here. If I got this right, let me just double check. I think I made one or two minor mistakes here. So I'll go from this point here to here, and this point here to here, and here as well. I got to do the same thing over here to close that shape. And now I've got a few of these defined. So let me just switch to my side view. And I can see that I basically could clone this throughout this pattern here. So I'm just going to select just those objects that I want to clone. These ones here, here, and here. And also the objects along the top. And I'm going to Control-C to add them to my clipboard. And then I'm going to go back to the clone tool. So I'm going to click on the clone tool here. And I'm going to say, let's set up my clone. In this case here, it's going to be, again, about the rotation about the z-axis. And I need to basically specify how many copies I need. So in this case here, I'm going to go with a 4.5 degree increment. And I believe here, if I've done my math correctly, I'll need 19 copies. If I overextend, that's fine. I can always delete the extra objects. But let's just click OK to see what happens with this. And I want to be in the negative 4.5 degree direction, because at the direction of the right-hand rule, it would actually be going in the negative axis. So we can see here that it's produced these additional elements along that path. I'm going to unselect all and then clear my clipboard. And you see that it has created a few extra elements along the extension of my space truss here that I'm going to get rid of. So hold down Control with the excuse me, I'm losing my words, member definition tool, and the same thing with the joint tool. And now if I look at the 3D view of my model, it's going to start resembling my space truss. I also want to rotate this since it's not in the global coordinate system orientation that I want, so I can just simply go to the edit menu and I'll go to the move tool and let me rotate this 90 degrees about the x-axis. And we can see now it's starting to resemble the space truss that we might intend to have drawn. I'm going to do the same thing to add some additional column to support this. I'll use a one joint method. And I'm going to just extrude this column in the negative z direction. I'll say 5,000 millimeters or 5 meters down from this endpoint here. I also don't want this to be a truss. So let me use the member type tool to just reverse that. And I'm going to apply a support. And lastly, let's just go to the loads tool and add just as a test, I'll add a self-weight load. -1 in the z direction. Click OK. And go ahead and run the analysis. So linear static analysis. And we can see that we get a clean solution. And now when I'm in the graphical results window, I can look at things like the deflections, the deflected shape. I can look at my reaction forces in different directions, as well as my axial forces and moments if they were to exist. I could see those here. So that's a quick kind of exercise for going through the creation of this type of circular or arched space truss using S-frame. We hope you enjoyed it, and if you'd like more tutorials like this, please check out our YouTube video.